Let's take a look at the final equation for lesson 6.5. F of x equals 4 plus the square root of 2 minus x. You'll notice on the graph below, I've already sketched the parent function. Please pause the video and do the same thing. When you're done, press play, and then we'll go through the rest of this transformation. To sketch the graph of f of x equals 4 plus the square root of 2 minus x, we first need to take a look at the domain. The domain will help us create our table. What's unique about this equation is that it's 2 minus x. That's what's on the inside of the square root. For the domain then, if we set 2 minus x greater than or equal to 0, we're going to be able to determine values for x that will make the inside of that square root possible. Now when we subtract 2, this seems like kind of the same stuff we did before. We get negative x is greater than or equal to negative 2. And then to get x by itself, we have to divide by negative 1. How many of you remember the rule of what to do in an inequality when you divide by a negative? We have to switch the direction of the inequality sign. And that's going to be something meaningful for our description as well. On the right, negative 2 divided by negative 1 is just positive 2. So this is our domain. And what's unique to note about this as far as the description, if the arrow is a less than arrow, less than means, or less than or equal to, for a square root function, less than means we're actually going to reflect over the y-axis. And that's part of our description then for this function. The other part of the description will be that plus 4. So notice the plus 4 is outside of the radicand, so it's going to shift up or down. And that plus 4 just means this whole thing is going to move up 4 units. And remember, we'll get all of that to play out when we create our table. We know what number to start with. We're going to start with this 2 over here. So I'm going to create a big table. And we'll start with that key number. If we plug in positive 2, we have 4 plus the square root of 2 minus 2. 2 minus 2 is 0, and the square root of 0 is 0, so that gives us 4 plus 0, which is 4. That's one ordered pair. Let's see, what else can we pick? Notice it says x has to be less than or equal to 2, so we can't go to 3 this time because that would give us a negative value inside the square root. We have to go the other direction. A number that's less than 2 could be 1, and if we type that in, we should get a perfect square root to simplify. 2 minus 1 is 1, the square root of 1 is 1, and 4 plus 1 is 5. There's another valid point that we can plot on our system. We could type in 0 for x, that would be true, but we'll get a decimal answer. You're okay to get a decimal answer, but again, if we can figure out another number that would make it a perfect square root, it's just easier to graph those integer values. If I go over to negative 2, watch what happens to the inside of that square root. We have the square root of 2 minus negative 2, but watch this, that becomes positive, and 2 plus 2 is 4. The square root of 4 is 2, that makes 4 plus 2 equal to 6. So hopefully you're following how I'm generating those values. The next perfect square that we'd want inside the square root is 9. What number could we plug in for x to get us positive 9 on the inside of that square root? We'd have to go all the way over to negative 7. And that would give us 4 plus, on the inside, 2 minus negative 7, which would ultimately then become 2 plus 7. Let me get that negative in there. There's plus 7. 2 plus 7 is 9. The square root of 9 is 3. And 4 plus 3 is positive 7. Let's plot these 4 points to see if we get the shape of that square root function to happen. First, I'll plot 2, 4 over here in quadrant 1. Put a big dot there. And then I have to go to 1 and up 5. Okay. Go to negative 2, and I'm going to be up to 6. So now you can kind of start to see that curve starting to turn a little bit. And then watch this one. If we go to negative 7, 7, we can definitely see that curved shape happening. Now we have to start at this ordered pair. And we're going to curve to the left because those values are going to get smaller and smaller for x. So your shape should look something like this. Kind of curve that over here. Whoops, make that arrow happen. There we go. So it's reflected over the y-axis, which means the arrow is going to point to the left, just like the domain does. Interesting to note. The direction of the inequality for the domain is the same direction as the arrow on the graph. And it also moved up 4 units from that parent function. Here's your last example for lesson 6.5.